Okay, for 2.8, again, let's look over some more operations on the functions. Um, let's look at f of x being and g of x. So let that be 4x plus 5. So now, let's do this with no actual value for x, but just keeping the variable x in there. So first, let's do f plus g of x. And then let's do f, f minus g of x. Again, this is just like, you can write it just as this, and this one can write just as this. Now, we need to do the legwork for f of x and for g of x, but we've actually already got that. We've got it right here and right here for both of these questions. So what you're actually going to do is just go ahead and plug them in and subtract or add them. So technically don't need this yet. So we've got f of x, which is x squared minus 3x, and we're going to add g of x to it. So the x squared stands alone basically, so that'll just drop down. Kind of mark it off just so you know you've brought it down already. Negative 3x plus 4x, that'll leave you with a positive x. Mark those off since you know you've already dealt with them. And there's no other constant, so the plus 5 will just drop down. Okay, so now we've got that. Now let's do the f minus g. So again, we've already got our outcomes. So x squared minus 3x minus g of x. So 4x plus 5. And notice I did the parentheses around g of x. That's because the negative sign out front needs to be passed through the whole function of g. So let's go ahead and pass that through. So that'll be negative 4x minus 5. Now we can combine like terms. So x squared drops down. Negative 3x minus 4x is going to be negative 7x. And then the negative 5 drops down. Okay, so now we've got both answers. What would happen if I asked you what the domain was of each one of these? So remember the domain. My pen's not working. Domain. This is referring to your x values. What x values can you plug into each one of these? Well, the f plus g of x, the domain of this, we need to look at this here, and we need to decide what x values can we plug in here and what ones maybe can we not. Well, technically, by looking at it, you should see that no matter what x value you plug in there, you're basically going to get a unique y value or an output. So for this one, your domain is this. Now for this one over here, basically is the same thing as the logic I used with this one. Let's just think of x values that can get plugged in there and what ones that we cannot. Just by looking at it, you should basically be able to tell there's really no restrictions on it. It's not being divided by anything. You know, there's nothing down here, so that would give you a restriction. So basically your domain here is going to be negative infinity to infinity as well. So let's do two more examples. Okay, now let's do it where we multiply and divide. So we can have f of x times g of x. And also we can have it as f of x divided by g of x. So let's start with the left-hand side, f times g of x. Basically, we're just going to multiply them out with parentheses. So now we just need a FOIL. So multiply these two together. So we're going to have 4x cubed. Multiply these two together. It's going to be positive since they're both positive. Pen's not working. Well, that's 5x squared. Okay, so now let's take these two, multiply them together. One's positive, one's negative, so the outcome's going to be negative. You take the coefficients, multiply them together. Now you take the variables and multiply them together. Now multiply these two together. So one's negative, one's positive. It's going to be a negative outcome. Multiply the coefficients. 3 times 5 is 15. And we only have one variable, which is x. Okay, so now we just have to combine like terms. So the 4x cubed, and there's only one of them, so that's going to drop down. The 5x squared minus 12x squared, you're going to have 5 minus 12, so that's going to give you a negative 7. And then the variables, they just drop down. And we only have one left, so that will drop down as well. So this is what we end up on the left-hand side. So moving over to the right, basically, again, we just plug them in. So we've got x squared minus 3x divided by 4x plus 5. And actually, just by looking at it, nothing's really going to cancel out very nicely. So technically, this is your answer. Now, you have this answer here for the left, and the much easier answer to figure out was on the right, where we basically just plugged it in and was done, since there was no simplification. But now, what if we ask for the domains of these two? Starting with the one on the left, basically this is going to be like the previous two that we had just done, where we can plug in any value for x, and you're going to get some output. So your domain over here will be negative infinity up to infinity. And if you're confused on how I'm looking at this, we covered section 2.3, and it does talk about this much more in depth, but there's no restrictions on this, so there's nothing being divided by it. So there's nothing down here which would cause a restriction, and it's not set equal to some value that would cause a restriction. So basically you don't have a restriction on your x value, which is your domain. But for your right hand side, we do have a restriction, and that restriction is the denominator. We do not want the denominator, we cannot divide by 0, so therefore we need to figure out what makes this 0. So what we can do is simply take the denominator, set it equal to 0, and solve for x. So we would subtract 5. And it's not working. Why? Okay, well that's supposed to be a 4x. Sorry, it doesn't really look like it, but and we're going to divide by 4. Okay, so the only restriction on this is that x cannot equal negative 5 over 4. Because if you had negative 5 over 4 and you plugged it in for x, you would end up getting 0 in the denominator. And we cannot divide by 0. So the domain in this, on the right hand side, is going to be negative infinity all the way up to negative 5/4. Pen's not working. Sorry. And then it's going to be union with negative 5/4 up to infinity. So as you can see, I drew parentheses around negative 5/4 on both sides. So if you were to look at it on a graph, here's negative infinity, here's negative 5/4, and here's positive infinity. So we have an open circle here, and we could go anywhere on the x-axis. Here's your y at 0. You could choose any x value except this one for the right hand side. So your domain is everything except that.